Assalamualaikum warahmatullahi wabarakatuh. Assalamualaikum and very good um, day. So, so this is the continuation of the uh, power transmission topic. Okay, so previously we have um, discussed on the short length line representation, which is very simple and straightforward. Okay, and today we will continue on the medium length line representation. So the medium line representation is used for line with length of between 80 kilometer to 240 kilometer. All line parameters are still represented as lump elements, but however for this medium length line representation there are two ways on how we analyze this one based on the model. So we have two different models that we can use, which is the first one is the T-circuit modeling or representation, and the second one is the pi circuit representation. So this is the model of the T-circuit representation for the medium length line. As you can see right now in this figure, this is a per phase equivalent circuit. The impedance are divided into half as shown here, and in the middle we have admittance, okay, where the value is JBC. So I would like to highlight this. So the admittance is actually Y is equal to J omega C. Okay, and we have Vs, Is, IR, and also VR. Okay, so we will do the same thing with the medium length line for the T circuit, where we need to have the matrix that relates the Vs and Is. So we need to have the parameter of A, B, C, D that relate Vs, Is, and VR, IR. Okay, so in the next slide we will actually do the analysis on to obtain this value A, B, C, and also D. Okay, so this is the analysis to obtain the parameters A and B. So this one is actually Vs. So this is actually the what we call the voltage drop. Okay, so Vs is equal to Vs is equal to Is multiplied with Z over 2, okay, plus this one, which is IR multiplied with Z over 2, okay, and plus VR. Okay, so the KVL is flowing like this. Okay, so this is the equations, and since we want to actually represent Vs in terms of IR and also VR, so we need to replace this, rewrite this. So Is is actually is equal to this one. Okay, so this is your Is. Okay, and then we simplify, and finally we will obtain that the parameter of A and also B. So your A is 1 plus Z Y over 2, while the B parameters is Z plus 1 over 4 Y Z squared. The second one is actually to obtain the IS relationship between for in terms of IR and VR. Okay, so this is the equation. So IS is equal to IR plus VR plus IR Z2. So where this come from is actually come from this one. Okay, so IS right now, so the this is the point KCS, so this is IR IS. So IS is equal to IR plus the current here. So the current here, we notice that this is a VR. Okay, so you need to VR multiply with Y. Okay, okay, so IS is equal to IR plus VRY. Oh, sorry, this one is not VR. Okay, I am very sorry. This one, the voltage across here is not VR, but actually the voltage across this admittance is actually VR. Okay, the voltage across this is actually VR plus IR Z over 2. Okay, so this is the voltage across this admittance. So we have VR plus IR Z over 2. And then we rearrange this. So finally, we will obtain your C parameters is equal to Y, while the D parameters is equal to 1 plus 1 over 2 Y Z, which is you can actually written in the matrix form like this. This is the T circuit representation. Okay. Next is actually the pi circuit representation. So as you can see here, we have the impedance, but right now the admittance is divided into half. Okay, so the same thing we will do for this pi circuit representation, where we need to find the relationship of Vs and Is in terms of A, B, C, D matrix in value of in the equation of IR and also VR. So the first one is actually to obtain the Vs equations in terms in IR and VR variable. Okay, so this can be obtained by using the KVL, which is Vs is equal to 1 plus 1 over 2 YZ VR plus ZIR. And this actually can be simply obtained from the KVL. Okay, so this is your Vs. So this is your KVL. Okay, and the current here is actually IR plus VRY over 2. Okay, so actually Vs is equal to IZ plus VR, where I is IR plus VRY over 2 multiplied with Z plus VR. Okay, so you will obtain these equations, which is A is equal to 1 plus 1 over 2 yz, while the B parameters is z. And the second equations is actually on the IS. So your IS is equal to y over 2 Vs plus y over 2 Vr plus IR. So this can be simply done from the KCL of the circuit. Okay, so we notice that this is IS. So we need to find the current that flowing here and also the current that flowing here. So this is my I1 and this is I2. So I2, which is we have already obtained, is actually equals to IR, okay, plus VRY over 2. While I1, okay, your I1 is actually Vs multiplied with Y over 2. But right now, we can actually write down like this, Y2 Vs, okay, plus IR plus VRY over 2. But since this is IS, so we need to replace this Vs, and Vs is actually the voltage of this KVL. Okay, so your Vs is actually equal to I2Z plus VR, and this I2 is this one. So we replace this, as you can see here, Vs we replace with this formula. Okay, and then after you have rearranged this, finally we obtain the C parameters, which is y plus 1 over 2 y squared z, and the D parameters is 1 plus 1 over 2 yz. So this is in the matrix form, and this is the example. So a three-phase 50 Hz transmission line with a length of 160 kilometers is connected to a load of 500 kilowatt with unity power factor at 30 kilovolt. Okay, so the length here is 160 kilometer. The power factor is unity. The power at the receiving end is 500 kilowatt, while the voltage is of the receiving end is VR equal to 30 kV, okay, with an angle of 0. So because we are always referring the receiving end as our reference, okay, but this one is a V line, okay, so this is a V line, so we need to convert into V phase first. So VR phase, so it's equal to 30 kV square root 3, so and then the angle is 0. So this is our VR phase. Okay. The line conductor has series parameters of 0.24, okay, with impedance with a reactance of 0.47 ohm per kilometer, and the shunt parameters, which is your admittance, which is given as a 3.75 power of -6 per kilometer. given that the conductor of the line are arranged symmetrically with distance between phase conductor of 3.1. So please ignore this one. Okay, we actually didn't consider this. Calculate the sending end voltage using T and pi circuit representation for the line. So this is the solution. So please ignore this solution here. So the series impedance which is given, so you need to multiply with 160 kilometers. So you will obtain this is your Z total. And the admittance, which is your Y, you need also to multiply with the kilometers. So this is your Y total. Okay. So the phase voltage at the receiving end is this one. So this is VR phase, which is 1730, and as you notice, the angle should always be actually 0 degrees because VR phase is our reference. And the phase current, we can always refer to the power over the square root 3 multiply the V line, and then the power factor is unity. Okay, so since the power factor is unity, so the angle is actually 0, meaning that the voltage and current of the receiving end is in phase. And using the T circuit representations, okay, by using the equations of A, B, C, and D parameters, you will obtain the Vs is equals to this value. So please be noted that this is V phase. Okay, so in order to get the V line, what you need to do is actually to multiply square root 3, and the angle should be at 30 degrees. Okay, so we'll obtain that your V sending end is equal to this value. What about the sending end current? So the sending end current is actually same. You can use IS is equal to CIR plus, sorry, VR plus DIR. Okay, so finally you will obtain this one, the value. And once again, this IS is the phase current. If you want to okay, so phase current. And using pi circuit representations, okay, same. So you need to use the pi circuit representation, the A, B, C, D for the pi. You will actually have the same value, okay, even though you are using pi or T circuit. The value is actually almost the same. Okay, and then this is the V phase. So to get the V line, you need to square root 3, and then the angle you need to actually add with a 30 degrees. So you will have this value which is the same with the T circuit representation. And the same case goes to the IS. Okay, so the IS value is also the same, 14 with an angle of 48.1. Okay. So that's all for the medium line representation. For the next lesson, so we will actually go for the power transmission efficiency and also regulation. So thank you very much for your attention.